Hello, this is Lab 4, Magnetic Field of the Bar Magnet, Physics 2212. Overview. First we get into a brief introduction, then we'll go into the physics involved, then we'll look at some observations, and followed by the code model, and then our results and some key takeaways at the end. Introduction. Purpose. The purpose of this lab is to measure and observe the distance dependence due to a bar magnet, and compare these results with that of theoretical results predicted by the and derived from the equations in Biart-Savart law. Results preview: n equaled -3.333 and mu equaled 1.5. Physics involved. Fundamental principles and equations are the Biart-Savart law, the distance dependence of a bar magnet, and the magnetic field of a dipole by these equations respectively. Observation. Observed model. The initial conditions of the observed model were using the bar magnet and the magnetometer on our phones and measuring the magnetic field of the bar magnet using a set distance with a meter stick. The system was the bar magnet and the surroundings are the rest of the universe. Observed model. I have the calculations for my observed model in this graph here, as well as the specific set data points recorded at R20, R70, R120, R170, and R220, which gave us these calculations via the Excel sheet, and then I entered in data so I could get the off-axis field. Some of our observations were that when the phone was far away, it measured a near zero, and as it got closer, it increased greatly. Glow script model. In the glow script model, I made a few changes where it said to in the commented part of the codes and adjusted it for the data we found in the lab. And it predicted our off-axis fields and our on-axis fields, and then output specific data for each of these points. Glow script code results. So here are the results of that code. It outputted this image showing us the vectors for some of the relevant forces, and it gave us the field on axis and the fields at several perp locations. And it showed us the diagonal displacement and the magnetic field at a 45-degree displacement, and what the force was, and the magnitude of that force. Results. The off-axis fields differed greatly, and in this lab we assumed the bar magnet acted as a dipole so that we could easily apply Biart-Savart law, and we assume the external forces are negligible. Assuming that the bar magnet acted as a dipole is a potential source of error. However, it is likely mostly negligible in our lab and for our purposes. Key takeaways. What if you hadn't oriented your experiment to compensate for magnetic north and it had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? The Earth's magnetic field would have interfered with the field of the bar magnet. What if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? The magnitude of the field would likely have doubled, retaining its same direction. Thank you.